Captions in English, please. So this is the 5th video on chapter 2, and it's on uncertainty in measurements. So every instrument has a limit as to how it can be used, and this is called the uncertainty. A measurement always has some degree of uncertainty. A digit that must be estimated is called uncertain. And so a measurement will include the certain digits and the first uncertain digit, the estimated number. So it's all the certain digits, and there is only one uncertain digit, and it's the last one to the right of measurement, to the right of the number. And so the certain digits, including the uncertain digits, are called significant figures. So altogether, all the digits, the ones that are certain plus the estimated one to the right of the number, are called significant figures. And significant figures are a way to show the uncertainty of a measurement. For example, scientists have measured the average global temperature rise over the past 100 years to be 0.6 degrees Celsius. What does this measurement mean? It actually means that the uncertainty in the measurement is such that we know the measurement is between 0.5 and 0.7, or 0.6 plus or minus 0.1 degrees Celsius. So how do we get that range of 0.5 to 0.7? Is that the digit to the right, the estimated digit, and here it's the 6, you add 1 and you remove 1 to that last digit, and you get the range from 0.5 to 0.7, or 0.6 plus or minus 0.1 degrees Celsius. And so the estimated digit is the one to which you will add or remove 1 to it, and that will give you a range of value. And you know for certain the measurement is between that range, and it's not beyond that. So, for example, our measurements of 0.6 degrees Celsius or 0.60 degrees Celsius or 0.600 degrees Celsius, are they the same? No, they are not, because in 0.6 we add plus or minus 1 to the 6, because that's the last digit to the right, it's the estimated digit. But in 0.60 we add plus 1 or minus 1 to the 0 to the right. So the range will be 0.59 to 0.61 degrees Celsius. So it's a narrower range. And now in the example of 0.600, you add 1 and remove 1 to the last 0 to the right. And so the range becomes 0.599 or up to 0.601. And so you see how the range becomes smaller and smaller as you have more digits. And so the number of reported digits reflects the precision of the measurement. And the more digits it has, the more precise it is. You can see how the range gets narrower and narrower when we add zeros to the right of the 6 here. So let's talk about accuracy and precision, and make sure you understand the difference between the two. They are not the same thing, even though people use them interchangeably. It's not. It doesn't mean the same thing. Accuracy defines how close the measurement is to the true or real value. And so, for example, in the case of a target, like we have here on the right, the true or real value is symbolized by the center of the target. So the accuracy defines how close your measurement is close to the center of the target, for example. Precision defines the degree of reproducibility. So how repeatable is the measurement? So are you able to always get a measurement that is very close to the previous measurements? If you are able to have measurements very close to one another, then you are very precise. And so if we look at the targets there, The first one on top. What can we say about the accuracy and the precision of those shots? There is 4 shots. So what about precision? Precision here is not good because the dots, are far apart from each other. However, accuracy is good because in average, you are very close to the center of the target. So at first it might be surprising, but accuracy is good if you take the average of your measurements. And then if the average is close to the target value, the true or real value, then you are accurate. But you are not very precise if you are having such shots spread out like that. In the second target, the one below, we see that all the shots are clustered into one area. So we can tell that the precision is very good. It's reproducible, it's repeatable. You are able to always shoot in the same place. So measure in about the same value. However, you are offset from the center of the target. It's shifted to the left. So this makes it a low accuracy measurement. So let's practice or let's learn how to do a measurement of length using a ruler, a metric ruler in centimeters. And so let's just say that the length of the pin here will occur at about 2.85. And so how do we get that measurement? If you look at the first drawing of the ruler, you can see that the end of the pin, so if you align the pin to the 0, you can see that the end of the pin falls between 2.8 centimeters and 2.9. So the little lines are millimeters, but we will report the measurement in centimeters. And so from 2, you can count, so the line that is halfway is 2.5, and then 2.6, 2.7, 2.8. And then you have the end of the pin, and then after that it's 2.9. So you know for sure that it's 2.8. It's between 2.8 and 2.9. What you need to do next is estimate between the two lines that are visible and that are known for certain. So you imagine that the distance between 2.8 and 2.9 is divided into 10 equal parts. And then you estimate where the end of the pin occurs. And here there is a zoom out of where we would see it fall. And so the long lines are 2.8 and 2.9, and we have divided the space between 2.8 and 2.9 into 10 equal spaces. And we can see that the end of the pin falls about at half the distance, and here then we can say that after the 8 it's a 5. So the uncertain digit is the 5. And so depending on the person who measure this, the 5 here can change. Somebody else could say it's 2.84. Somebody else could say it's 2.86. And these are all correct suggestion or measurements because the last digit to the right is the uncertain one and it's estimated. So the rule is to always estimate between the smallest division. So there is the length, you know for sure, and then always estimate between the smallest division. So let's practice by reading some glassware. How would you read each graduated cylinder using the correct number of significant figures? So let's start with the the larger graduated cylinder that goes up to 5 milliliters. So there is something particular about graduated cylinders is that typically the water or the liquid that you pour in them makes a meniscus at the surface of the liquid, and usually the meniscus is curved upward on the sides, and so the rule is to read the volume at the bottom of the meniscus. So you need to read at the bottom of the minuscule. So if you look at the surface of the water in that cylinder, you want to read there where the red line is. So if we look at the graduations of this graduated cylinder, this line here represents 2.2 because the line below is 2.0 for sure, right? This is certain numbers. And then the line above, because you see that the space between 2 and 3 is divided by 2's. So above it's 2.4 and above it's 2.6. And the line just below the red line is 2.8. And so this graduated cylinder, you can only estimate to the 0.1 milliliter. Here you could estimate that it's between 2.8 and 3, and so you would say 2.9. But here it's much closer to 2.8, so you will stay there at 2.8. So the volume in the large graduated cylinder would be read as 2.8 milliliters, because you cannot give more precision than that. If you know, if the volume was falling exactly between 2.8 and 3.0, then you would say it's 2.9. And that would be, so the 8 and the 9 here are estimated. Let's read the smaller cylinder. Again, it's the space between the measurements that are given is by 2's. So from 0.2 to 0.3, we have, and so let's mark where we will read first, at the bottom of the meniscus, so here. And so this line here is 0.20, because you're right on the line. Next it's 0.22, then 0.24, then 0.26. And the red line then falls on 0.28. And that's how you can read this. It's the volume in this small cylinder would be read as 0.28 milliliters. If the bottom of the meniscus would be falling between 0.28 and 0.30, you would estimate it at 0.29. So that's as far as you can be precise in these cases. When you read beakers, beakers are very uncertain volumes. They have very few lines, and so that makes them less precise tools to measure volume. So let's start with the left beaker here. You can see that the lines are marked every 20s, but there is also a line every 10s. So you have lines every 10 milliliter here. So that means you can estimate between, for example, 20 and 30. Even though the 30 is not written down, there is a line for it. So you can estimate. So that means you can read to the 1 milliliter, because if you go from 20 to 30, you can, you know, in your mind, visualize that you are cutting this space into 10 equal spaces. And so that means you can give a value that is to the 1 milliliter. So here, the volume of the beaker, of the liquid in the beaker here, falls where we have the red arrow. And so below we have the line for 40, and above we have a line for 50. And it's in between. So you estimate between 40 and 50 where that arrow falls. And it's not quite the middle. So the way I would read this is as 44 milliliters. You can tell it's below 45. So 44 milliliters here. So you see that the estimated digit is at the place of the 1 milliliters. Beaker to the right. So same graduation here, every 10 milliliters, and this time the liquid seems to fall on the line. So this would be read as 50, right? That line represents the 50 milliliter mark. But to say that you are able to read to the 1 milliliter, plus or minus 1 milliliter, you would do a dot after the 50 to show that the 0 is significant here. Let's practice some more with a 100 milliliter graduated cylinder that is filled, between 40 and 50 milliliters. So here again we have a line to show the bottom of the meniscus, because it is important here that as you can see, this is a real picture, and you can see that the meniscus, makes the liquid move up the walls of the container everywhere. So when you are looking on the side and put your eye at the level of the meniscus, there is like a thickness to the meniscus. And so you need to read where the meniscus is the lowest, so at the bottom. So the red line shows where you should read. So here, what do we know for sure? So we have the line for 40. The smaller line above is 41 milliliter. The line above 42, then above 43, again 44, and then the line in the middle here between 40 and 50 is 45. So that's 45 milliliters, and so the line above that will be 46. So the volume is between 45 and 46, and we know for sure then it's 45 at least. And then we need to estimate between 45 and 46 where is the bottom of the meniscus falling. And so here I would say 45.6 or 7. So the volume here in the large cylinder would be estimated at 45.7, but maybe someone else would say 45.6 or 45.8, right? So the last digit here is the estimated digit. It's the one that carries the uncertainty. And that's the one to which you add 1 and subtract 1 to get the range where you know for sure your volume is. So let's practice one more time with a smaller graduated cylinder, a 10 milliliter graduated cylinder. You can see we have a long line for the 4 and then a long line for the 5. And so we have lines in between every ones. So the first line above the 4, the line for the 4 represents, so 4.1, right? Here it's 4 already, so we need to do 0.1 for the first line above the 4. Then 0.2, 0.3, 0.4, 0.5 is the middle line, and then 0.6, 0.7, 0.8. And so you see that the bottom of the meniscus here is above 4.8, but below 4.9, right? So these two are 4.8 and 4.9. And so you estimate the space between the two. Imagine you cut it in 10 pieces, equal pieces, and try to see where the meniscus falls. And here I would say 4.87 again. I would estimate that it's, above 5. It's higher than half of the space. So 4.87, for example, would be the volume for this liquid here. And that's the 7 here is the estimated digit and the uncertain digit. And so let's practice now to read metric ruler. So we have a metric ruler, and the numbers here are centimeters. The 1, the 2, the 3, 4, 5, 6 are centimeters. Millimeters are the smaller lines. But we will read that in centimeters. So here we can see that the nail, goes from 0 to about 5. It's longer than 5. So we know for sure it's 5. And so it's even slightly more than 5. So we would say 5.1 for sure. So we know that it's 5.1 for sure, because if we draw a line here, it's slightly after the 5.1 line. So you know it's between 5.1 and 5.2. And so you need to estimate between 5.1 and 5.2, you know, what you can add to that. And so it's really close to 5.1. So I would say 5.11 or 5.12 centimeters. So 5.11 centimeters or 5.12 centimeters. And so in millimeters, it would be 51.1 millimeters. So make sure to read the unit properly here. In 1 centimeter, there is 10 millimeters. So we usually read in centimeters, but you can also read in millimeters. And so pay attention to use the proper number for each.